Okay, we are discussing about the jet transforms. We are rewinding this unit, right? So up to here we discussed in the last class. So now we are going to discuss about this. Find the jet transform for the signal x of n equal to sin n omega t into u of n. So jet transform of x of n equal to sigma n is minus infinity infinity x of n into z power minus n. Here x of n is sin n omega t into u of n. So u of n is given, that's why it is varying from 0 to infinity. So sigma n equal to 0 to infinity sin n omega t into z power minus n, right? So as we already know that sin theta is e power j theta minus e power minus j theta by 2j, right? Here it is given as a sin n omega n. So this is a sigma n equal to 0 to infinity e power j omega tn minus e power minus j omega tn by 2j into z power minus n. Or we can write this as 1 by 2j into sigma n equal to 0 to infinity e power j n omega t into z power minus 1 whole power n minus sigma n equal to 0 to infinity e power minus j omega tn into z power minus 1 whole power n, right? It is equal to 1 by 2j into z by z minus e power j n omega t minus z by z minus e power minus j n omega t. So by taking LCM and multiplication, so it will become 1 by 2j into z square minus z into e power j n omega t minus z square into uh, z square plus z into e power minus j n omega t by z square minus z into e power n omega t plus e power minus j n omega t plus 1. Or it is z into e power j n omega t minus e power minus j n omega t by 2j by z square plus 2z into e power j omega t plus e power minus j omega t by 2 plus 1. So it is nothing but sin omega t. It is nothing but cos omega t. So it is equal to z sin omega t by z square minus 2z into cos omega t plus 1. Right? This is the z transform for sin n omega t into u of n. In the same manner, we can find the z transform for cos n omega t into un. That is, by solving this, we can find the answer as x of z equal to z square minus z cos omega t by z square minus 2z cos omega t plus 1, right? So next problem is to find the z transform for the signal x of n is equal to x of n equal to 2 power n into u of n plus 3 power n into u of minus n minus 1. Okay, so x of z is sigma n equal to 0 to infinity, since it is u of n. So 2 power n into z power minus n plus sigma n is minus infinity to minus 1 3 power n into z power minus n. So for this, this is z by z minus 2, and for this it is 3 by 3 minus z minus 1. Okay, it is z by 3 minus z or minus z by z minus 3 for ROC mod z is less than 3, and this is for mod z is greater than 3. So it is z by z minus 2 minus z by z minus 3. Here ROC is in between. Here ROC is in between 2 and 3. Z is in between 2 and 3, right? 2 is less than mod z is less than 3. Okay. So we can draw the ROC for this one. First ROC of term A is this one. So this is ROC is greater than 2. So mod z is greater than 2. And for term B, mod z is less than 3. Okay. We have the ROC. And in between 2 and 3, this is the ROC. In between 2 and 3. Next problem is find the z transform and switch ROC for the sequence x of n equal to delta of n. Okay, x of n equal to delta of n. So z transform of x of n is sigma n equal minus infinity to infinity x of n into z power minus n. Here x of n is delta of n, but delta of n exists only at n equal to 0. So it is n equal to 0. It is, its value is 1. So at n equal to 0, it is 1 into z power minus n. So z power minus n, n's value is also 0, so that it will become 1. So x of z equal to 1, and here the ROC region of convergence is entire z plane. Next problem is find the z transform and switch ROC for the dt sequence x of n equal to b power mod n. B power mod n. Okay, b power mod n can be written as b power plus or minus n. So we can expand this as sigma n equal to minus infinity to infinity b power n into u of n plus b power minus n into u of minus n minus 1 into z power minus n. Okay, so is sigma, it is u of n means sigma n equal 0 to infinity p of n into z power minus n, and u of minus n minus 1 means it is varying from minus infinity to minus 1. Sigma n equal minus infinity to minus 1, b power minus n into z power minus n. Okay, so by solving this, we can get 1 by one term is 1 by 1 minus b into z power minus 1, that is 1 by 1 minus b by z is nothing but z by z minus b, and here ROC is mod z is greater than b, and for term b it is sigma n equal minus infinity to minus 1 b power minus 1 z power minus 1 whole power n. So as we already see this type of problems, so let p equal to minus n, so minus p equal to varying from minus infinity to minus n. So n is replaced by minus p, so that it will become sigma p equal to 1 to infinity bz power p. By adding 1 and subtracting to this expression, it will become sigma p equal to 1 to infinity bz power p plus 1 minus 1. Okay, or we can write this as 1 plus sigma p equal to 1 to infinity bz power p minus 1. Okay, so it is sigma p equal to 0 to infinity bz power p minus 1, or it is 1 by 1 minus bz minus 1, so that it will become bz by 1 minus bz, or bz is less than 1 or z is less than 1 by b. So by adding these two terms, it will become x of z equal to z by z minus b plus zb by 1 minus bz, right? So here ROC is b is less than mod z is less than 1 by b. Okay, so suppose so that it will become, by adding these two terms, it is z by z minus b plus zb by 1 minus bz, and here ROC is in between b and 1 by b. Suppose b value is 2, then it will become z by z minus 2 plus 2z by 1 minus 2b, 2z. Okay, so here the ROC will be like this: b is 2, then 1 by b will be 0.5, 1 by 2, that is equal to 0.5. So here the ROC is in between 0.5 to 2. 0.5 and 2. So next, coming to the properties of jet transform, as we already discussed in our last classes, like properties of Laplace transforms. Here also we have the properties of jet transforms. So first property is linearity property. So how it is defined? The jet transform of x of n is x of z, and the jet transform of y of n is y of z. Then jet transform of the weighted sum a into x of n plus b into y of n is nothing but a into x of z plus b into y of z. A into x of z plus b into y of z. Here ROC contains R1 intersection with R2, that is the linearity property. Next one is a time shifting property. If the jet transform of x of n is x of z, then jet transform of x of n minus n naught is nothing but z power minus n naught into x of z. So taking jet transform of x of n minus n naught, so it will become sigma n equal to 0 to infinity x of n minus n naught into z power minus n, or this is nothing but here, like n equal to n naught and n equal to n naught, then it is x of n into z power minus 1. So if n equal to n naught, then it will become x of 0 into z power minus n naught plus x of 1 into z power minus of n naught plus 1 plus x of 2 into z power minus of n naught plus 2, and so on. So by taking z power minus n naught is common, this is x of 0 plus x of 1 into z power minus 1 plus x of 2 into z power minus 2, or it is nothing but z power minus n naught into x of z. Okay, z power minus n naught into x of z. So this is nothing but the z transform of x of n minus n naught, z power minus n naught into x of. Next, frequency shifting property. If the z transform of x of n is x of z, then z transform of e power j omega naught into j power j omega naught n into x of n is nothing but x of e power j omega naught into z. So substituting e power j omega naught as z naught, so it is equal to z naught power n into x of n. So z transform of z naught power n into x of n is nothing but x of z by z naught. So taking z transform sigma n equal 0 to infinity z naught power n into x of n whole power z power minus n So it is x of n into z power minus n by z naught power minus n, or it is nothing but x of z by z naught. Here ROC is z0 R1. Okay. Next, time reversal property. If the z transform of x of n is x of z, then z transform of x of minus n, z transform of x of minus n is x of 1 by z. Okay, here ROC equal to 1 by R1, x of 1 by z. Next, coming to the convolution property, z transform of x of n equal to x of z, then z transform of y of n is y of z, then x of n convolved with y of n, that is z transform of x of n convolved with y of n is nothing but product of x of z and y of z. So convolution in time domain will become simple multiplication in frequency domain. So here ROC is R1 intersection with R2. Okay, that was already proved in our Laplace transform convolution. Same procedure. Okay. Next, differentiation in Z domain. So if Z transform of x of n is x of z, then Z transform of n into x of n is minus z into d by dz of x of z. Okay. So x of z equal to sigma n equal to 0 to infinity x of n into z power minus n. Differentiating both sides with respect to z, we get d by dz of x of z is equal to sigma n equal to 0 to infinity x of n into d by dz of z power minus n. So it is equal to dy dz of x of n is equal to sigma n equal 0 to infinity x of n into, so d by dz of z power minus n is nothing but minus n into z power minus n minus 1. Okay. So it is by taking the negative sign at the left side. So z minus z into d by dz of x of z is equal to sigma n equal 0 to infinity n into xn into z power minus n, n into xn into z power minus n. Okay. Next one is scaling in Z domain. So if Z transform of x of n is x of z, then a power n into x of n, Z transform of a power n into x of n is nothing but x of z by a. Okay, a is any real or complex quantity. So Z transform of x of n is sigma n equal 0 to infinity x of n into z power minus n. So it is sigma n equal 0 to infinity a power n into x of n is nothing but into z power minus n. So a into z power a power minus 1 into z whole power minus n. Okay, so that is x of a power minus 1 into z, that is x of z by a. Next, initial value theorem. If x of n is causal, then x of 0 equal to limit n tends to 0 x of n, that is equal to limit z tends to infinity x of z. Okay, if x of n is causal, x of n equal to 0 for n is less than 0, right? So what is x of z? X of z equals sigma n equal 0 to infinity x of n into z power minus n, right? So it is equal to x of 0 plus x of 1 into z power minus 1 plus x of 2 into z power minus 2, right? Okay, taking limits on both sides, for z tends to infinity, we get the limit z tends to infinity x of z is equal to limit z tends to infinity x of x of 0 plus x of 1 into z power minus 1 plus x of 2 into z power minus 2, etc. So it is nothing but x of 0. So therefore limit z tends to infinity x of z is equal to x of 0, that is the limit n tends to 0 x of n. So then final value theorem. Final value theorem is if x of n is causal, then x of n equal to 0 for n equal less than 0. So x of infinity is equal to limit n tends to infinity x of n, that is equal to limit z tends to 1, z minus 1 into x of z, z minus 1 into x of z, right? So we have z transform of x of n plus 1 is equal to z transform of x of z minus x of 0. Similarly, z transform of x of n is equal to sigma n equal 0 to infinity x of n into z power minus n, right? Z power minus n, that is equation number 2. So equation by subtracting equation number 2 by equation number 1. So 1 minus 2 is equal to z transform of x of n plus 1 minus z transform of x of n, that is equal to z transform of x of z minus x of 0, z transform of x of 0 minus x of minus x of z. Okay, that is x of z into z minus 1 minus z into x of 0. So sigma n equal 0 to infinity x of n plus 1 minus x of n into z power minus n is equal to z minus 1 into x of z minus z into x of 0. Taking limits z equal to 1 on both sides. So limit z tends to 1. Sigma n equal 0 to infinity x of n plus 1 minus x of n into z, 1 by z power n is equal to limit z tends to 1, z minus 1 into x of z minus z into x of 0. Okay, so sigma n equal 0 to infinity x of n plus 1 minus x of n is equal to limit z tends to 1, z minus 1 into x of z minus x of 0. Okay, x of 0. Here we are applying z is 1, z for n is 1, n is 1. Okay, so z power minus 1, that is 1 by z. Z get cancelled, so it will become limit sigma n equal 0 to infinity x of n plus 1 minus x of n is equal to limit z tends to 1, z minus 1 at x of z minus x of 0. So limit z tends to 1, z minus 1 into x of z is equal to x of 0, so 0 plus sigma n equal 0 to infinity x of n plus 1 minus x of n, or it is equal to x of 0 plus limit m tends to infinity sigma m equal 0 to m x of n plus 1 minus x of n. So by expanding this, we get limit z tends to 1, z minus 1 and x of z equal limit m tends to infinity x of m plus 1. If m equal to m tends to infinity, m plus 1 also tends to infinity. So RHS is limit m plus 1 tends to infinity, that is n tends to infinity x of n. So x of infinity equal limit m tends to infinity x of n, that is equal limit z tends to 1, z minus 1 into x of z. These are the properties of our jet transform. Properties of our jet transform. Next we will see the problem. Find the jet transform of x of n is equal to 1 by 2 whole power n into u of n minus u of n minus n. Okay, so jet transform of x of n equal jet transform 1 by 2 whole power n into u of n minus u of n minus 10. Okay, right. So it is equal jet transform 1 by 2 whole power n into u of n minus jet transform 1 by 2 whole power n into u of n minus 10. So as we already know that time shifting property. So jet transform of 1 by 2 for whole power n into u of n is nothing but z by z minus 1 by 2. Here not z is greater than 1 by 2. Time shifting property u of n, z transform of u of n is u of z. Z transform of u of n minus k is z power minus k into u of z. Similarly, n minus 10 is z power minus 10 into u of z. So therefore, by solving this, we can get x of z is 2z power 10 minus 1 by 2 whole power 9 by z power 9 into 2z minus 1. So here mod z is greater than 1 by 2. Mod z is greater than 1 by 2. So next we will see the inverse jet transforms. Okay, next see the inverse jet transforms. Okay, we will discuss in our next class. Okay, with this I am concluding the today's class. So thank you.